Okay, well, welcome to my industrial database portfolio project. This is the capstone project for the backend course. Uh, for this project, I decided to just continue with the profile project we used during the SQL portion of the course. So basically taking the SQL database, um, the Flask application, containerizing it, and then hosting it in the cloud. Um, for the industrial database, here's the ER diagram. So essentially what you see is something you typically see in kind of any manufacturing facility. You have some pumps and motors moving stuff, speed and flow sensors, which kind of measure the flow rate, through each pump and the speed of each motor that drives the pump. I also included some time series data here, which you can get via the APIs. So that's kind of neat. And then on the other side here, you had some information about pump models and the vendors who sell those pump models. So the idea here is like kind of if some sensor showed some bad values, you could quite easily get a replacement pump for that model and get the information for the vendor. So that's kind of the use case. Um, I actually use this use case because of my background working in engineering and like with industrial digital twins. So most of the data here is actually just mocked up. First, I'll show you the Swagger API. So if you haven't worked with Swagger before, essentially what it is uh, it's a way that users can see documentation for APIs um, in a website and actually test calls to that API as well, all from one location. So you don't have to kind of switch between help documents and a tool like Insomnia. You can just do it all in one place. There's actually two versions of the API. There is one, so you can see up here it says API v2. There's another version that works just with Insomnia. Yeah, so I can show you a simple example of how this works. So, for instance, if you wanted to get a list of all the flow sensors, you can just clear that out. You can go and hit execute, and basically what it does is runs a git command to get all the flow sensors and then lists it here. If you wanted to like test it, you could go to a post command if you wanted to add a sensor. And we can just add in some dummy information here, for instance. Current value is 1, max is 10, minimum range is 0. Model is like, you could say it's just like my sensor model or something. And then you can also connect it to one of the pumps. So you could get this from a git command for the pumps, but for now we'll just attach it to number 3. So just execute that. Okay, and then you can see that it sends the return back as well, so that looks like it's created. If we do then update our git command here, then we should see it here at the bottom. Yep, there it is. All right, terrific. Hosting. This is all currently hosted on Azure. It is a Flask application. Um, the database or the application consists of 3 containers. There is if we go to workloads, there's a Flask application here, a Postgres database, and then also a PG admin server as well. It was part of the thing, so I hosted it here in Azure as well. Instead of using like Azure databases, I just containerized the Postgres database. And instead of using Azure container registries, I just continued to use the Docker Hub registry just for cost purposes and simplification a little bit. Nothing too much interesting. Oh, I also reduced, if you go to the nodes here, the node pools, you can actually, I reduced it from like a D2 size to a B2S. So that's a neat little burstable virtual machine that is a lot cheaper to run if, for instance, you don't need a lot of traffic or very great performance. One thing I've kind of learned in the past is that deploying containers can be more cost effective than using Azure services like Azure Functions or database services like Cosmos DB. So just kind of wanted to test that. When I go to my code base here, I don't think there's anything too exciting to show. So you can see it's broken down here. And this is, of course, all on GitHub, and I'll link it. Yeah, so we have the Flask application here. If we go into the source, there's actually two versions of the APIs, one for the Insomnia and one for Swagger interface. So that's kind of neat. You can pull the Insomnia collection here if you're curious on testing it. I also included some PyTest data. The tests aren't very great, but they run and kind of show the use case. And then down here, of course, you can see Docker and the Docker Compose and all of the YAML files for uh, building the Docker containers and then the Kubernetes environment. Okay, yeah, so I guess a few big challenges I had. First was just like really understanding the configuration for Flask and Docker and understanding all these YAML files and how it applies here. The exercises we had in the course were a little bit simplistic, I'd say, and didn't always have multiple containers that needed to talk to each other. So that took a little bit of research. And second was really understanding how Flask worked with other packages. So, for instance, like Flask SQL Alchemy and Flask PyTest and a couple others. So I kind of had to start from scratch to really understand how those are set up and used and what they do. So once I'd worked through it a couple times, it is a lot better. So overall, I'm happy with my project. I've started setting up the CI/CD pipeline with GitHub Actions. There's a couple challenges there, getting like GitHub synced up with Docker Hub and Azure, but I don't think it's anything too major. So I'm looking forward to having that done and finishing the project soon. Thank you very much.